welcome to another exciting episode of Doug's Electronic Repair Bench.
Good morning, YouTube. Back with you today for this little demonstration. I have a lamp here. It is a standard desk lamp, I guess you would call it. It runs off of household current, and I'm going to show you exactly what it takes to light this lamp. As you can see, I have this is a standard outlet, nothing fancy about it. This is to simulate the ground plug on your three-prong plug. It fits into the round circuit there, round socket there. Now the other thing that I have is a plug that has been altered, obviously, and you can see half of it is black and half of it is white. That's to simulate the wiring in your plug, which is wired the same way. The hot is black, the neutral is white inside the receptacle there. So that when I connect this hot wire up to the lamp and the other pin connects to the ground pin, you're going to see that this actually works. You'll see it on this meter here as well. But here, watch what happens when I plug this in. I have light. I have voltage. This, the reason I'm doing this is because what the isolation transformer does is isolates whatever you're working on from earth ground. This is earth ground right here. Okay, that it just isolates it to where you're not, there's no shock potential. I should say it lessens the shock potential, so that if you come in contact with something ground, like if I was barefooted and had you know, a wet floor or whatever, and my feet would be grounded, I would be grounded. And if I touched that hot wire there, this wire here, I could very well get a severe shock or even death. Okay, so that's the idea I want to prevent. I don't want to be able to plug in anything and get an earth ground path back to earth ground, because you know, that's just the way that works. Here I'm going to show you what happens when you reverse the plug to this one. Nothing happens. The potential of this wire here and this wire here is the same. It is exactly the same. They are connected inside the breaker box. They are connected, this wire and this wire. So they are the same thing. This is the only hot wire, the black one. And like I said, you can see it does light the light. And I must have lost my connection on the meter. Yeah. Put that back on. There we go. Now, anyway, that's what that does, and I just wanted to prove that to you, that it's the ground path that we're trying to protect everybody from here. And so what I'm going to do now is set the isolation transformer up to where we're using the output of the isolation, the isolated output. And I want you to see that. If you can't see it, it says isolated output. Okay? Now, I want to, let's set this up and I'll come right back to you. Alright, back once again. Now, what I've got set up here again is the earth ground connected to the lamp. The lamp is not lit. The other wire is connected to the output of the isolation transformer, the hot outlet, a hot side, if there is a hot side to an isolation transformer. And you can see it is on. I'm going to show you what happens when we remove the ground plug from here and connect over here to where, oh yeah, there you go. There's your voltage. Okay, so you can see there's no connection from the isolation transformer to ground. That's the thing we're trying to avoid. And that's what the isolation transformer does, is keeps you from having a shock potential there on whatever you're working on. This is used for what so-called hot chassis radios and TVs. Those chassis actually connect to one half of the line cord, and depending on how you plug it in, it could be hot, could be neutral. But anyway, again, I'll take it off there and put it back in here, and there's no light. So you can see we have no ground potential. The meter is 0, and that's what the isolation transformer does. And like I said, it protects you from that shock hazard of the ground potential. So I don't know if that explained it very well. But anyway, I wanted you to notice also that I had 117 volts out of the from the isolation transformer. It's only on 80%. This when it's cranked up all the way to 100%, it puts out 150 volts there. Now, that is very shocking voltage. So, while the isolation transformer does protect you from that ground, accidentally touching ground and touching the radio chassis and getting a shock, there is still the same voltage available inside that radio that there was if you just plugged it into the line voltage. It's no different there. Like I said, so the shock potential is there, even though it's lessened somewhat by taking the ground loop out of it. Like I said, it's kind of complicated, and I just wanted to show you what this little thing does, and I hope this did show you. And if you guys got any questions, I mean, I have told you guys over and over again, I am not a very good teacher. I've tried to show this best I can, and like I said, that's what this isolation transformer does, and that's all it does. And this one happens to be a variac at the same time, so it's variable voltage from 0 to 150 volts total output. So that's just my little demonstration on this, and I hope you guys maybe learned something or didn't learn something. I don't know, but like I say, please, if you have any questions, ask me. I'll be happy to answer them. I don't want anybody to think when I said isolation transformer, this thing just protects you from everything. It does not do that. It just takes one specific hazard away from working on hot chassis, and that's what it's for, and that's what it does. So guys, thank you for watching, and like I say, if you have any questions, comments, leave them. I'll be happy to address them, and I hope you all have a wonderful day.